Today, we will be addressing three main questions. 1, what have we learned about the deepwater blowouts that we didn't know at the time of the spill? 2, what do we need to know in order to more safely produce oil from the deep ocean that we don't now know? And 3, what is it that researchers in the Sea-Image Consortium and other researchers will do over the next 3 years, and how will that contribute to our state of knowledge of deepwater spills?
When the blowout happened in 2010, we can see on the right the release at the wellhead. This was an enormous release of high pressure, high temperature petroleum, which is made up of oil and gas, into the bottom of the ocean. One part was dissolved components. So normally you think that oil and water don't mix, but in petrochemicals, there are parts of petrochemicals where oil and water actually do mix, and the oil components can dissolve into the seawater. The second component was generated by the formation of what they call micro droplets. These very, very, very fine droplets of oil between 20 to 60 microns thick, which is about as thick as a width of your hair. And these essentially were both the dissolved component and the micro droplet component led to almost an invisible layer of petrochemical between 900 to 1,200 meters thick. But when you brought it up and did the analyses, you could document that there was a significant amount of petroleum in the subsurface. Our colleagues at the University of Miami are able to make numerical models integrating both theory and evidence that shows essentially the fate and transport of this oil in the water. And what you can see is a heat map where the red colors represent large droplets and the small droplets are represented in blue. And you can see the large droplets go quickly to the surface, but the micro droplets are at depth and are retained at depth. And you can see how they're channeled into the northeast, into the DeSoto Canyon region, as well as to the southwest. And these plumes in the subsurface would impinge upon the continental slope environment in the DeSoto Canyon and to the southwest. We utilized an instrument called the multi-core, which you can see in, which is a spider-like device, and you'll see it on the boat, on the Weatherbird. And that device can capture sediment cores in the Gulf of Mexico, and importantly, retain the surface of that sedimentary core, which is quite critical for recognizing the most recent points of deposition. On the right-hand side, you can see an actual core that was collected in February of 2012. Essentially, what we're able to do here is you can see how a sedimentary layer, which essentially is associated with the timing of the Deepwater Horizon. What we're able to do is essentially utilize those sediment cores, slice them very finely, and conduct chemical analysis of them. What we were able to discover is a process which was called the flocculent dirty blizzard. Essentially what it does is it links the clay minerals, the algae, the oil and dispersant mix, and they are able to bind together and be ballasted to sink to the bottom. We've made estimates that anywhere between 4 to 10% of the liquid oil released is actually located in the bottom and having effects on the biota, namely the small organisms that live into the sedimentary environments. So these are the kind of results that we have been able to get from the understanding of the behavior of the oil and gas released at high pressure, high temperatures into the cold ocean bottom, as well as looking at the transport of these, the mechanisms for how you can get oil onto the bottom, and ultimately how it has a biological and ecosystem impact. And questions are really, as you come back to baseline, what is that baseline? And ultimately, how long will the recovery take?
We are academics doing research, but we're not doing academic research. We're doing research that actually is supposed to help the policy decision and policy making apparatus in the United States. And so we're trying to focus this research on practical things that we need to know in terms of actually assisting this industry and assisting society in making these tough choices. Clearly, the Deepwater Horizon, as an unprecedented four-dimensional oil spill, has resulted in the necessity of actually understanding and forecasting where these deep plumes go, both at the surface and the subsurface. First of all, we're going to be monitoring the changes in the sedimentary system and the fishes over time. As I said before, one way we can back into baselines is to understand what's happening in these fishes, not only in terms of their contamination level, but the sublethal impacts on their reproduction, their growth rates, and other things that are important that determine physiology. And so we'll be monitoring in this northern Gulf of Mexico area. And so one could select any point in the Gulf of Mexico and run the forecasting models of where the particles would go and understand the impacts on these resources. So this represents an important planning tool. There are enormous questions that still surround the controversial use of dispersants at the wellhead. There are models and some intriguing experimental results that indicate that perhaps that was a very minor component of the formation of those deep plumes. If that's the case, then why authorize nearly 1 million gallons of dispersants to be used at the wellhead if it's basically not doing anything useful? And so this remains an extremely controversial result. And so we will get to the bottom of this question about whether the dispersants actually made any difference in terms of the formation of small droplets, which are so critical to this question of deep plume formation. One of the next major initiatives we have is what we're calling Return to Ixtoc. And in fact, in 1979 and 1980, there was a major oil spill off the Campeche region in the Gulf of Mexico. The spill itself was at about 50 meters depth, or about 150 feet, but it was perched on the edge of a major submarine canyon there. What we're going to do is do an expedition back there because we know from some of the work that we've already conducted that a substantial fraction of the oil from Ixtoc also lies on the sea bottom. And so our idea here is basically to use the past to predict the future. So we think that by doing these comparative studies, we can actually forecast into the future what the deep waters around Deepwater Horizon will look like 35 years from now in terms of the toxicity and impact on the environment.